Hello everyone. In last lecture, I was explaining this example. So my question is 4 and 5, 4 or 5, 4x or 5. In this case, I am getting a 4 output. In this case, I am getting a 5 output. In this case, I am getting a 1 output. So how it is internally working? So if you want to see one more time this output, then I will practically prove Java C test.java Java test. Okay, sorry, Control S. I forget to save this file. Java C test dot Java Java test. So see here 451. So my question is how it is internally working. 4 and 5, 4 or 5, 4x or 4, 4x or 5. Okay. Line by line I will explain. So that's why I need to open my paintbrush. Paint. Okay. This is a paintbrush. First line is I will copy this line. See. Okay. How this line internally working? First tell me, 4 represent in the form of a binary, that is a 100. Okay. How 5 is represented in the binary format? 101. Okay. What is the rule for the AND operator? If two operands are true, then only result is a true. So in binary, 1 represents the true and 0 represents false. So 01. In this case, 01 means 01 means 0. Okay. 00 means 0. Okay. Then 1 means 1. That's why I am getting 1 0 0 0 0 1 0. And 100 represents in the form of a decimal, that is a 4. That's why in this case I am getting a 4 output. I hope you are understanding. If you don't know anything about this operator, let's check my previous classes videos, and then you have a clear idea about how AND operator internally working. This is the first line. Second line is OR operator. How OR operator is working? If one operand is a true, then we will get a true output. Yes, correct. 4 represent with 00, 1015, 11. Here 11, 1, 0, 01 means 1. That's why I'm getting a 5 output, because 100, 101 represent in the decimal format with 5. Okay. Third line is XOR operator. What is the rule for XOR operator? If two operands are different, then we will get one output, means true output. Yes, correct. So 100, 101. So in this case, 110 means two operands are not different. Then 0 again, 00 same. 01 means different. That's why we will get one output, means one result. Okay. And 001 in the form of a decimal, it represented by 1. That's why in this case I am getting a 1 output. Okay. I hope you understood this example. In next, we will discuss bitwise complement operator. Oh, what is the bitwise complement operator? Let's see. I think I covered already, but I will delete this. Okay. Next operator is a bitwise complement operator. Bitwise complement operator. Okay. This operator represent with tilde symbol. I will write here. This operator is represent with tilde symbol. Okay. Let's see about this operator. Test dot Java. System dot out dot println. Then I apply this operator like to. In this case, what output we will get? Let's see. In this case, we will get minus 3 output. Then, sir, how it is working internally? I everything I will cover. So don't worry. Java C test dot Java test C minus 3 output. If I write here 4, then in this case I will get 5 minus 5 output. CLS Java C test dot Java test minus 5 output. Yes, correct. So here the formula of output is always n equal to minus n plus 1. Remember this shortcut. Remember this shortcut. When we apply this operator on integral types, then we will get always output as n equal to n plus 1. The minus symbol. Okay. Let's see this operator is working for boolean types or not. If I write here true, here is Java C test dot Java. Immediately we will get bad operand type boolean for unary. This operator is not applicable for boolean types. Remember this point. This operator is not applicable for boolean types. Okay. Example. By mistake, if you apply, then immediately we will get compile time error, bad operand. Okay, bad operand type boolean for unary operator. Remember one point here. This bitwise complement operator is internally stores the value in the 2's complement format. Okay. And here most significant bit or MSB acts as a sign bit, means 0 is positive and 1 represents negative. Okay. Next operator is a Boolean complement operator. Boolean complement operator. This operator is represented by exclamation mark. Here system dot out dot println for what output we will get in this case. Let's see. Java C test dot Java. Immediately we will get no. In this case we will not get any compile time error. Why we will not get any compile time error? So I will tell you each and every point. Java C Java test okay -5. Okay. This is a previous example. This is for the Boolean complement operator. Java C test dot Java. Immediately we will get a compile time error. Why we will get compile time error? Because Boolean complement operator is not applicable for the integral types. That's why I am getting here compile time error. I will write here example. In this case, I am getting compile time error. Compile time error saying bad operand type int for the unary operator. So this operator is not applicable for the integral types. Then what is the use of this operator? Let's see. Java test. This operator is applicable only for the false, means true and false values for Boolean types. If I write here false, then I am getting a true output. If I write here true, then I am getting a true output. Java C test dot Java. In this case, I am getting true output. Java test true output. If I write here true, then I will get false output. Java C test dot Java. Java test C false output. But how it is a working internally? This operator is used like a not operator. True converted into false and false converted into true. So this is the best example for Boolean complement operator. Okay. Output in this case false. Next bitwise operator is left shift operator. For this operator, you need to understand example. If I write here a equal to 1, a equal to 1, int a equal to 1, and a left shift 1 or 2. Let's see what output we will get. Java C test dot Java test 4 output. How 4 output is getting? So try with yourself and tell me how it is internally working. Left shift, right shift, and unsigned right shift.